Hi everyone, today we're gonna start with chapter 10 in your geometry book. This is lesson 10.1, areas of parallelograms and triangles. In this lesson we will learn how to find the area of a parallelogram and a triangle, with different cases for each of them. A parallelogram is a quadrilateral. Quadrilaterals are shapes with four sides. So this is a shape with four sides, and it's a simple quadrilateral with two pairs of parallel sides. So this side is parallel to the opposite and this side is parallel to the opposite. Each two opposite sides are parallel to each other, and each two opposite sides are also equal to each other. The length of side AD equals the length of side BC. Also the length of side AB equals the length of side DC. The opposite angles are equal as well. A and C are equal. B and D are equal. So this is what we call a parallelogram. A quadrilateral with two pairs of opposite and equal sides and two pairs of opposite and equal angles. A rectangle is a special parallelogram when all the angles are 90 degrees angles or right angles. They both have four sides. Each two opposite sides are equal and parallel, and each two opposite angles are equal and parallel. But for a rectangle, all the angles are 90 degrees angles or right angles. So they have the same formula to calculate the area. Let's start with the rectangle. The area of a rectangle is the product of its base and height. To find the area of this rectangle, we just multiply the base length, which is 8, times the height, which is 3. And this is equal to 24. Centimeter times centimeter is centimeter squared. That's why the area is always measured in squared units, because you multiply two units. Now, what about the area of a parallelogram? The area of a parallelogram is the product of a base and the corresponding height. To be able to determine the area of the parallelogram, we need to find the height. We need to take one base, any of the bases, and the height on this base. For example, the area of this parallelogram is equal to the base, which is 10, times the height, which is 5, and this is 50 centimeters squared. Now we can notice that if we have a rectangle with base B and height h, it has the same area of a parallelogram with base B and height h. You need the same number of squares to build the rectangle and the parallelogram. We said that in order to calculate the area of a parallelogram, we need to find the product of the base and the height. For this parallelogram, for example, let's say that the base is BC. Actually, it can be any of the sides. It can be AB, AD, BC, or DC. The different thing is the height. It depends on the base you choose. If we choose BC as the base, the height will be the altitude drawn from the opposite side, which is side AD, to the base BC and perpendicular to it. The length of this altitude is the height. Let's say that we choose the base as CD, for example. We draw the altitude from the opposite side. Let's say from here. This is going to be the altitude. If we take AB as the base, the altitude will be somehow like this. So this is going to be the length of the altitude. If we take AD as the base, the altitude will be, look, I can draw it from this point, from point C, and this is the altitude. Or I can draw the altitude from B on the extension of AD. So I extend side AD and draw the altitude on the extension of this side. So this is the altitude when the base is AD, and the length of this altitude is the height. So the base can be any of the sides, but the height is the altitude from the opposite side on the base you chose. Also, the altitude can be outside the parallelogram. So again, the base of a parallelogram can be any of the sides. Let's choose side BC, for example. The corresponding altitude is a segment perpendicular to the line containing the base, which is CD, drawn from the side opposite to the base. It should be drawn from side AB because it is opposite to the side we chose. So we can say that this is the altitude, or I can choose any other point on the line, but I prefer the corner because it's easier. But I can draw it from this point, for example. Or we can extend this line and draw it outside the parallelogram. It has the same length as this line segment. Now, is the rectangle a parallelogram? For any quadrilateral to be a parallelogram, every two opposite sides should be equal and parallel, and every two opposite angles should be equal. For the rectangle, every two opposite sides are equal and parallel, and every two opposite angles are equal. So yes, a rectangle is a parallelogram. What about the rhombus? Every two opposite sides are equal and parallel, and every two opposite angles are equal. So yes, the square is a parallelogram as well. The trapezoid is not a parallelogram because these two sides are not parallel to each other. Let's start solving the problem to understand how to apply the formula to find the area of the parallelogram. Firstly, let's remember the formula. To find the area of a parallelogram, we need to multiply the base times the height of that parallelogram. What is the area of each parallelogram? Here the area is the base times the height on that base. If I choose this base, the 4.5 inch, the height on this base is not given, so it will be hard to determine it. But if I choose this base, the 5-inch base, I have the height on this base, which is 4. Then the area of this parallelogram is equal to 20-inch squared. So always the area is measured in squared units, according to the unit of the length you have. What about B? What do you think? Again, the area is the base times the height. The base is 2 or the length of this side. Actually, it's 2 because we take the base of the parallelogram, not the base of the shape we created to find the height. This is the base of the parallelogram and this is the height on that base. So it's 2 times 3.5 and this is 7 square inches. Pause the video 4 minutes and check your understanding by solving at it 1. Let's do it together now. What is the area of a parallelogram with base length 12 meters and height 9 meters? Just multiply the base 12 times the height, and this is the area of the parallelogram. This is 108 meter squared. Actually, this was so easy. Let's go to some harder questions. For parallelogram ABCD, what is DE to the nearest tenth? We need the height DE. Now notice that the height on side AD is given, which is 9 inches. So we can use side AD and the height 9 to find the area of this parallelogram. So let's start by finding the area, then we can find the missing dimension DE. The area is equal to, again, the base times the height. The base is 13 and the height is 9. This is equal to 117 square inches. Now we have the area. We can use 117 to find this height. Again, the area is equal to the base times the height. But now I will take AB as the base, which is 9.4 inches, times the height, which is DE, and this is missing. Let's call it X. And A is 117. X is 117 divided by 9.4. X is equal to about 12.4 inches. Here we learned how to find a missing dimension. If we have other dimensions by finding the area first, then we can substitute the area for other sides to find the missing side. Now to understand more, we need to solve questions 1 and 2 of the lesson check on page 619. Let's start with question number 1. Find the area of each parallelogram. The area of this parallelogram is the base, 20, times the height, which is 10, and this is 200 meters squared. For question 2, the area is again the base times the height. Actually, we cannot take this as the base because the height is on this base. But this base is also 8 feet because we know that for any parallelogram, each two opposite sides are equal. So this is 8 and this is 8, and the height is 8 as well. So this is 8 times 8, which is 64 feet squared. This is enough for today. Actually, we finished part 1 of this lesson. In part 2 of this lesson, we will learn how to find the area of a triangle. See you next time.